Another design example or another possible question that the interviewer might ask you is, design a basic search engine database. You are given millions of URLs. How would you create your database so that a given query string of 2 words, how to find the URL which contains all the words of the query string? The word can come in any order. So you have a basic search engine database. Design a basic search engine database, right? You are given a list of millions of URLs. This is the first stage, the use case or the information gathering stage. And the user of the system will provide query string, and we need to return URLs which contains all the words of the query string. It is some kind of search engine, so we can pre-process the data and make our database, right? This is the first stage, which is the use case. The requirement analysis. In the requirement step, you need to find out how many users are going to use the search engine. In our case, we asked the interviewer and they responded. So we are not supposing or assuming anything, that there are not many users who are going to use our system. So the main concern is the database. So the SOAR, what's that? The SOAR concern database. All right, maybe we have n numbers of machines that can be used to fast our data pre-processing, to speed our data pre-processing. To speed it up, we will be using n number of machines, right? The users are not that much. This is not really a good answer. Usually they give you a number. It's less than 1,000, it's less than 2,000, it's just in hundreds, it's just less than 200, just something like that, right? Yeah. Because it's relative. If you say is not many users, this word is really differs. When you go to a small country, the many is something not like when you go to a highly populated country. It's really relative, you know. All right, stage 3 is the basic design, and the step will make the basic design. So let us make a working system with just few URLs. How would you find the required URL from a given URL which contains all the words from the input query string? You can make a hash table in which words are the key and document IDs are values. So hello reflects these URLs, world reflects this URLs, and you see the search. To search the document which contains hello world, we find the intersection of the two lists. So we have 1, 2, 3, and 2, 4, 5. We have the two in common. In addition, URL2 is the result, so it provides this. This is just an example. The bottleneck. What are the bottlenecks in this design? In this step, we will look back in our original problem in which there are millions of URLs that we need to be pre-processed. There may be a number of different words, so it may be not possible to create the whole hash table on a single machine, because the millions maybe might not fill the RAM, right? Therefore, we may need to divide the hash table and keep it on a separate machine, on separate machines. We need to retrieve the URL that match a given word efficiently. We need to retrieve the URL efficiently, like fast, so that we can find the intersection. Pre-processing, all in the millions. URLs by a single machine will be slow. We need to find a way to parallel process pre-processing step. We need parallel processing to speed it up, to be efficient, to be responsive. Scalability. Let us look into the problem of keeping hash table in different database. One solution is to divide the words alphabetically. We can make tables corresponding to each word. Each database contains tables of words under some range. For example, the database 1 contains all the words which start with the alphabet A, and database 2 contains all the words which start with the B, with the alphabet B, and so on. Data is stored in the database, and when the database reaches its maximum capacity, the data is stored to the next machine, and a tree kind of a structure can be made. So a tree kind of structure can be made. When the database, like the first one, the first layer is for the A, B, C, D, and if it gets full, then we add a branch to it and we proceed. It will be like a tree, right? Finding the list of URL corresponding to some word is easy. You can go to the corresponding database and find the table and get all the data of the table. Finally, we can get the intersection of the results of various words. In addition, the result will be given as output. So we get the intersection and we display and generate the final results. All right, so we have these three stages. Pre-processing of millions of URLs with a single machine is slow. Therefore, we can divide a bunch of URL processing among a number of machines. Each URL processing is independent of each other, and the final hash table of URL can be finally combined. This approach of processing independent data and finally combining the result is used in MapReduce. So processing of independent data and finally combining the result. We studied the divide and conquer in previous chapters. This is kind of similar, right? MapReduce divides the input data set into independent chunks, which are processed in parallel. Speed it up. And then the output will be combined to get the result. Input data, processed separately. Get the results, right? Reduction is done here to the databases. Duplicate integer in millions of documents. This is another thing. Given millions of documents with all distinct numbers, find the number which occurs multiple times. So this is another example. We'll isolate it in a different video. We'll stop this for now, then proceed in a different video to cover this example. Thank you.